we got this over here. We're going to start breaking this loose here. We're going to vacuum all this up, get all the cast iron off of here, get this broke down over at the end of the table, and then we're going to do a test run, see how much better it aligns to the 90 degrees now. Hopefully right on the money, and we don't have to mess with it anymore. And everything is a nice clean machine finish now instead of hand ground. Look like somebody took a 4.5 inch grinder to it. Okay, I put one bolt here, and I have a toe clamp back here because the grooves don't line up, because this is made for the next size mill. I haven't made an adapter plate for this yet, and I may have to just lift this up again. But what we did is we went ahead and we put our dial indicator against here, and then my head sitting here lets us go back and forth, and lets me dial that same flat surface that's a machine surface that's in line with the pivot. Alright, and that's how I usually set this up to rough mount it on the table. Now we'll go ahead and we're going to loosen up these, and we're going to get this down. I'm going to pick up a polished bar. We're going to get down here, and then we'll go ahead and bring over one of the arms or something there. And we're going to have an indicator, two indicators, side to side and up and down. We're going to see about aligning the piece to the work. And we're also going to open up the jaws and make sure that we have enough clearance to actually chuck on the billet that we're going to be broaching. Let's go ahead. We've got this tightened down now. And this is just a piece of stock in here. It's like chrome rod. It has a little bit of rust buildup on it, but I'm just going to, okay, we got it all the way down. Now the first quick check that I want to make is to go ahead and find that the top of this, with this all the way down, is at least lower than it is over here. And as we move it this way here, we're climbing up and we're climbing up. So in that length right there, we're almost 50 thousandths higher here. So I know I'm past center. So we accomplished that, okay? Now the next thing I want to go ahead and test is to go ahead and pull the pin here and just rotate it around. And I'm going to go ahead and I'm going to take and rotate this like 150 or so, kind of hold it in here, maybe give it a spin. I'm just going to see if we can get it chucked up any different than that. And of course, I don't know if this rod is really running true or not. Okay, and also too, this may be setting down here. So let's do this. I'm going to give this a little lift right here, just so that I know that the chuck is not rubbing down here, because I think that's what's happening. Because I've seen this chuck really run true, and I think this piece of material validates that. Alright. Still getting about 6 thousandths, 7 thousandths. I'm going to rotate this around. Okay, now I'm getting about 2-3 thousandths. Now what I want to do basically is go ahead and cut that in the half, somewhere right in there. Alright, now I can go ahead and dial across the top here, and then we'll jack it up and down, and we'll tighten this up here. And like, if I can get it within 1,000 or 2 thousandths in that 1 foot range there, I'm going to be a happy camper here. Now I'm going to go ahead and set that at 0. It makes actually more sense to set it in here, but okay, there's 20. There's minus 22 right there. Now this is just a pry bar here, because I know that I can get right in here, and I'm going to gently lift that chuck up when I loosen the clamps right here. And I'm just going to bring it up to 0. We're probably going to need to go more, but we know that it has to go at least up to 0. And there's 10. I'm just going to crank the table to make my indicator change where I want it, which we're back to 0. Alright. There's minus 12. Same thing again. Now that's only plus 4. Okay, minus 4. Okay, that stayed pretty much plus 2 all the way around. Now, just for kicks, now I'm going to go ahead and rotate this 180. Just by eyeball on that line, I'm just going to take and spin this about 180. Okay, we're still plus 2. About plus a half. Alright, we're within 1.5 thousandths right now of running here, and I know that we weren't there before. So having the clearance in here lets me get on center when I need to get on center, and that's the main goal of this. Okay, now we're going to go ahead and we're going to open up the chuck before we get too fancy and actually setting our side to side. Actually, with that set side to side now, and we're going to go ahead and crank this because we know pretty much half of that's there, just because I know you guys are going, well, hey, what about the other way? Alright. And of course, center up and down is easy to do. You just crank it. And then when you hit that highest spot, that's 0. And then you crank it into where you're actually 0 on the dial. About plus 10 right there, so I would be bumping it side to side to get it. Like I said, this has got paint on it, but it's the machine surface that's close to a rough alignment on this head. Alright, back to checking our diameter and these jaws if we're going to have clearance or if we're going to have to block this up to run our hub. Check those again, especially if we have to raise this thing up. Now we open this up as far as we can go and have a swing around here. Okay, and actually right there we're hitting. Here we go. So our chuck, we have to create some clearance for this. They're out farther than our end bolting pattern here. What we're going to do is we're going to break loose both of these and we're going to swing it over the table's edge here with the jaws. Open it up and find out how much we need to raise this up on the average just for this job here. And we're going to kind of play with it. And I think we're going to go ahead and make our standoffs and our automatic table alignment parallels for this while we're at it. Because I'm going to need it for something else here anyway. So we're just bringing this down here so that this is hanging down, and I'm going to go ahead and open that. And the reason why, I mean, we could We could grab it out here and have these things inside. But we're broaching this, and we're gonna have loaded tool pressure coming in and hitting this thing. I want to butt into that against that chuck, and then we lock that chuck right down. Everything's gonna be locked down to the table, so we know that this isn't gonna be push free. If we're out here holding on either the inside or turning these around and hanging out on here, we're not gonna have 100% solid support behind the part. So this is why I'm trying to get this. All right, now that we got that's pretty close to being straight up and down. Okay, so how much is this actually hanging past the table? We're going to slide it down here so I can get my measurement here, and it's really like about 3/4, but we might as well go ahead and make 1 inch spacers. So 1 inch will let us at least get out to a 4.5 or so inch piece there, which is going to be fine. I don't know what the next job would be or how much larger we're ever going to run in this thing. And if it does get much larger, you know, turn around the jaws, is it really going to be that much, depending on what material. I've had the jaws turn around. I've done a ring this big with a gear, but it was a brass or bronze gear, a little softer material than this. Alright, so we know about 1 inch riser is what we need to create. So I'm going to hunt up some material, and we're going to create either one solid base or 2 parallels that will locate on each end. And we also got to lift this up so we can see what we got on the bottom for a key. We're in the Bridgeport. This is my second plate. I've already cut out one. And this is going to be a mirror image of this one here, because one is going to go on the front side of the dividing head, and this one here is going to go on the rear side. So we got one through bolt. We got another countersunk or relieved bolt that's going to bolt down to a T-nut here, and then we're going to have a threaded hole here that's going to catch the other side of the dividing head, so that this plate will be able to mount and grab all 4 supports, 2 and 2, on each end of the dividing head, and hold it 1 inch off of the table so that we have the chuck clearance. So that's kind of the name of the game right now. And we're going for a second hole here, and this is just a pilot. That was just a 17/32 hole all the way through. Alright, this is 17/32, and what we're doing is we're just going straight on through here. This is going to be another through hole, but this one here will have the countersink for the clearance for the nut and the socket to tighten it up. Alright, we're going to slow down some speed there. Okay, now we're going to put in end mill, which is going to come in spot base, a depth of 300 thousandths here. And we're going to bring our table up here so we're closer. Okay, there's 300. I actually remember we went 350 and 340. And there's 350. Alright, and I'm just going to verify. Yep, good. Alright. You have some depth here. Okay, and we're going to take it down some more. That looks good. Okay. Okay, bring it down touch. We've already set this for the diameter on the other one there, and basically we're just giving it a 32nd per side clearance on there. All right, put it on hand wheel. Lock our knee again. There's 0. Down there, we're just right at the bottom there. There we go. Okay. We're just dropping it down so we can get this out. Okay. All right. Back in with our drill chuck. Okay, we're just coming down and we're going to have to come up a little bit. Okay. There we go. Alright. Now we're going to come over here and do our last hole. And we're going to be coming over at 7.350. And we're coming back this way a 1/4 inch. Alright. And right there. Drill and tap. Alright, little countersink there. Alright, now we're going to move our belt down here a little bit here. Okay, and where we got that? Alright, here's a 1/2 inch tap. Nice and tight. Okay, make sure you have enough travel always on your spindle. Alright, otherwise you may pull the tap out of the chuck. Alright. Now I lightly just kind of follow the tap with my quill. Plenty of lubricant on here, tapping oil. Now we're going to go ahead and we're going to get the vacuum here a little bit so we can get rid of some of this trash here. Okay, now I just want to break the edges on the back side here, so I'm just putting this in here, and if I keep it slow, there, wipe these down and install them. Okay, we're gonna set this is where we want the end plate here, and we squared it to the table. I gotta grab my 3/8 drive here. All right. Now we measured the base. The base is 12 inches long. So our other plate will be 12 inches from outside to outside. So we're right in there. Alright, I'm going to go ahead and bring this table out so we can see what we're doing there. And we need 2 T-nuts down there. There's one. Alright. Go ahead and bring a cable back over here so we can lower it straight down. Alright, that looks good. Still got to get the nut on there, but I wanted to bring you around to this side so you can see that now we're able to index this with no problem, and we're holding it with the maximum draw of depth and against that face there, so all the stroke pressure is going to be against the dividing head, which is big enough to handle the load. Before I start putting this jumping jack on here, I just wanted to touch the bases. I believe I talked to this about this before in one of my K&T videos here. But basically what I have is I have one locator that fits into the 40 taper. Okay, and then I have 2 gears that I had to make up. And I had this universal head that was given to me, and I had this jumping jack or shaper head that was given to me. And of course I rebuilt this machine in 92, 93. I was complete in 94. And then I started Turn Right Machine Works, and I wanted to get these things operating, so I had to create the drive because the drive was missing on both of these, and that's part of the reason why I was given them. Of course, I mean, I was doing favors for the same person that Daryl Nate that you know, helped me procure this machine, and in turn he gave me these items, but it was missing the drive gear. Now this drive gear here, and I stamped them because I already had my turn right stamp when I started my own shop. I picked up the stamp, and I always have it turn right and then the year, the last two numbers. So this was in 96, but I actually started making this gear before 96 because I was actually making it before I started this one here, and I learned a little bit about gear making and the hardness of one gear to the next gear and the drivetrain and everything else. So I had to go with the recommendations of Worcester Gear. Worcester Gear is a very professional place to have your gear work done, and I recommend them highly, and they are the ones that help me cut the teeth in this gear here. This is a helical cut gear, and smooth operating gear. That's why it's designed in a helical motion. Now this jumping jack or broaching head was also missing the drive. Now it has a slide under here with a pin hole, and it was designed to be run with a pin sticking out of the spindle itself, and I created a almost identical component that locates exactly the same as I made this gear locate on the guide there, 4-hole pattern, and behind here, instead of having keys, I use round dowels, and you can machine a new dowel there, or you can go ahead and undo it and rotate it around a little bit. And so by having the small contact, it's just basically their safety, so that the regular tension and everything else you have on your arbor or your drive, if it happened to get loose, which you don't want it to get loose, the pins are the force of the drive. Alright. Anyway, this is stamped turn right 95. Alright. Now, so while I had this gear here started, which was going to be this blank here, but this was the wrong material to actually have the gear made out of, but it was hard enough to go ahead and create the drive for the pin. So that's how they got them switched around, and this was, by the time it was like the turn of the year, so it was like Christmas, wintertime work, and I was working on my own machinery and stuff like that, and creating my own parts, and I was wanting to get this head going. So this is marked 96. Now, so I made that already knowing what I needed to drive this machine, but I hadn't really redone this, okay? But I just happened to I did remake this slide, and this slide is stamped 1998. So after the fact of those gears being made in 95 and 96, I actually didn't finish having this running until 98. And that's when I completely went through and I even made a new slide, because somebody had, instead of engaging the pin where it's supposed to be in here, they got it right in between here, and anyway it caused damage. Then they ran it, and this was just beat to heck. Alright, and it was one of the, and this is misuse. You know, there's a lot of, you can put this thing in neutral, and when you set this thing up, you can actually tell that this is in here. If you had that pin in between here, you would have play. Alright, so it was clearly probably a 6-pack assembly or something, I don't know. Anyhow, I just wanted to touch bases on that a little bit. We're going to go ahead, and I'm going to swing you around to the other side, because I'm going to, or a different view here, because we're going to go ahead and we're going to assemble this on the rams, and then I got to loosen that up and move my gantry out of the way there after I get this up on here. And we actually slide this in and out on the rams, and the rams slide in and out, and that's how I'm able to rotate the spindle and also slide this side to side. I like it when it's in the horizontal, and I kind of stop it when it's in the horizontal as well. And it's easier to go ahead and you get it real close. And when you slide it on here, this pin, I radius this nose on the pin here, and it within a 32nd of an inch, it will slide this or rotate the spindle so that it pops together. Alright, So I just kind of wanted to touch that basis as far as these two items right here. They're accessories to the mill. They didn't come with the mill unless there was a tool queer like myself that collected these things and then sold you the machine. They were accessories after the fact, and they were probably pretty pricey. That universal head might have been close to 10 grand, maybe for that attachment there. I don't know what this attachment here was, and that's my guess. Okay, I'm not 100% sure what they were. They would probably seem like a ton of money when accessories to tooling was where that's always been where the money's at, and you know that they usually are mistreated just as much as machinery sometimes, and you got to go through and you got to make them right. And I love this thing every time I use it, and of course I don't use it that much, but I will be more and more into using it because of just picking up more things like blind keyways and stuff like that, and getting more accustomed to it. And also too, now that I'm modifying this index head here a little bit easier to get it up here and capable of opening the jaws a little bit more, and knowing that this completely comes down and is 100% 90 is going to be a great help for not just the quality of the work that I'm working with. Real short mill work, it's not that big of a deal, but when you got elongated components like splines, keyways, and so on, the axis has got to be true. And now that I know that I'm right on the money here, this is something I've been wanting to do for a long time. So yesterday was a great day. First thing I do is I stick the guide right in here and grab my 1 1/8" wrench here. Alright, just slightly snug it, just so it's in there. Alright, now we have two lineup holes here, and you gotta reel it. I made this really close. There we go. Okay, and we take our Allens, and these Allens work on both hubs. Okay, now we put this in neutral so that we can spin it and have it off to the side here, like that. And we know basically how far from center over here it is. We kind of oil up our rods all the way. Now when I got this thing, these were frozen in here, and a lot of guys say, hey, how did you get those free? Because what happens is people let them sit in here and then moisture gets down through the top there. They rust in there. People don't keep them oiled and lubed. Actually, when I got them, it took me almost 2 months to free those up. And I had pulled everything off of the top here, completely open, and I started soaking and soaking. And then I took a rawhide hammer and I would tap a little bit, tap a little bit. Finally, one night they started moving. And then I worked at them, got them, worked back and forth, just kept juicing it. I mean, it was running rust and everything else out of here. Finally, I did get them out, and I was going to make new ones. And of course, they're like 2 15/16 or some foolish thing like that, not a nominal size. But I was still going to get new rods. And one of my old timers says, "Why are you replacing them?" And I said, "Well, all these little nicks and dings." And he says, "Are they true?" Yes, they're true. Do they work? Do they fit tight? Yes, they do. You know, so I couldn't find any excuse not to use them. He says, "They're original. Keep them on there." And to this day, I'm glad that he talked me into keeping that original. All right, so I bring these over, and that was a pretty good guess there. Loose there. And let's see, I don't have this tight. You want to push on it, you gotta. Okay. As long as they're coming all the way through the bores there, you're good. Now I tighten them on right here.